right, ladies and gentlemen, I wrote this next problem a little larger. Again, I don't want to deal with microscopic. Dorothy, hush. We've got 1/3 times the log base b of x plus 4 times the log base b of y minus 5 times the log base b of x. We want to write this using exponential notation, integers or fractions for any numbers in the expression. So they don't want radicals, okay? All right. Now here's the tricky part to this problem. Before we even start, this term and this term are alike. Log base b of x and log base b of x are the same. So we need to combine those like terms before we start, just like we would in any part of algebra. 1/3 and a minus 5. So 1/3 minus 5 over 1. We have to get a common denominator of 3 here. So we have 1/3 minus 15/3 is negative 14/3. So what happens is, this one does not change. 4 log base b of y stays the same for right now. These two terms combine into one term, and they will be negative 14/3 times the log base b of x. So the important part on this problem was to start it right. And to do that, we combined these two like terms. Now, at this point, there's no more combining of like terms, so we're going to apply laws of laws of logs, which in this case is going to put the exponent of 4 back on top of the y and the exponent of 14/3 back on top of the x. So we have log base b of y to the 4th minus the log base b, let me get my hand out of the way, or my finger, of x to the 14/3. And we finish the problem by doing this. The log base b of one number minus the log base b of another number becomes the single log. So in other words, I write log base b one time. And by the way, let me make a comment here. If these two log functions were different, subtracting, we could not do this. We can only do this because they're the same function. Log base b becomes a single log base b of the quotient. Y to the 4th goes in the numerator, and x to the 14/3 goes in the denominator. And that is your correct answer, and oh, people, have fun typing that into Course Compass. That's going to be a pain, isn't it? Sorry about that. Okay, good luck with that one. But the trick here, if you see like terms, combine them before you start any of the laws of logs. Okay? There we go.